Okay, so the first formula they give you, probably one of my favorites, is called the point slope form. Okay, so last section, 1.3, we learned about the slope intercept form, which, to be honest with you, is pretty much how we write all of our equations. Sometimes we'll start it in what's called the point slope form. Okay, so the point slope form says this: y minus y1 equals m times x minus x1. Okay, so they will give you a slope. They will give you a coordinate x1 and y1. And you will plug it into this formula. This first y will always stay y. This will always stay. You'll always write a y here, and you'll always write an x here. These three, the m, the x1, and the y1, they'll change depending on what numbers they gave you. Okay. So real quick, we'll do two examples as to how to use the point slope form. So example 1, this section will say write an equation in slope intercept form. Don't freak out by that just yet. That passes through 1/5, 3/4. I'm doing fractions for a reason. And has a slope equal to 1/2. Okay, write an equation in slope intercept form that passes through the point 1/5, 3/4 and has a slope of 1/2. So notice they've given you three numbers: 1/5, 3/4, 1/2. Those are the numbers you're going to plug into x1, y1, and an m. This is your x1. I'm using the really, really orange one. This is your y1, and this is your m. And you're going to start, even though it says slope intercept form, you're still going to start right here. So you're going to leave this first y as y, minus y1, you're going to put 3/4, equals. Then you're going to put an m. What's your m? Your m is 1/2. Parenthesis. You just follow it along. It's a formula. It's telling you what to do. You just have to chug in some numbers. This x, leave it as x. So the first y and the first x don't change. This x1 is this number right here, 1/5. So minus 1/5. Okay? So now, from here, you want to clean this up. You want to put it in a slope intercept form, meaning you just want to solve for y. You want to put y by itself and then in equals x and then the y-intercept. So multiply, that would be 1/2 x. 1/2 times 1/5 is 1/10. And then let's see, y minus 3/4. You're going to add 3/4 over to this side. So you would add 3/4 to the 1/10. So y equals 1/2 x. And I'm sure you're not a fan of fractions. It's not that hard. You're trying to get them to have common denominator. They both could be turned into a common denominator of 20. So this would be, what, 2/20ths? And this one would be 15/20ths. And this is actually a negative. So you would have 13/20ths. If you don't feel comfortable about that, again, let me just go over this again, because I know I think fractions are annoying. But if you hit alpha window and go over to frac, and then you see that n/d, and then you type -1, 10. And then you add that to alpha window frac 3/4. 13/20 comes up. So again, if you're just feeling like, oh gosh, I'm not feeling great on the fractions, don't worry. You get a calculator. That's a good thing. Calculus 1, not necessarily a calculator. So be careful about that. But there you go. Y equals 1/2 x. That is the slope intercept form of a line, and it's going to pass through this point, and it's going to have that slope. So pretty easy. Let's do another one. Same directions, write an equation in slope intercept form that passes through (1, 7) and 3, 3. Okay. So what have they done now? They've tricked you. Okay, they've given you 2 points. Up here, they gave you a slope and a point. And you're like, oh, that was easy. I could just plug it into the formula. 2 points, which one do I plug in? Yeah, it doesn't matter. Okay, you need a slope and a point. A slope and a point. So we're going to start off by finding the slope. Let's find our m. Slope is, again, y2 minus y1. So again, if you have to label it, x1, y1, x2, y2. y2 minus y1 over x2 minus x1. So that's -4/2 or -2. There's your slope. That's your m. So you're going to plug m right in there, -2. What do you do about y1 and x1? Which point do you use? It honestly doesn't matter. You'll get the same answer if you do it correctly. Okay, so I'm just going to pick 3 and 3. So y minus y1 equals m times x minus x1. So this y will stay y. This y1, even though I'm using y2, it's okay, will be -3. M, we found out, was -2. This first x stays x. And then this x1 or x2 right here, in this case I'm using, would be 3. And then again, you have to solve for y. So you have to distribute the -2. -2x plus 6. And then add the 3 over. So y equals -2x plus 9. And that's finding an equation when they give you 2 points. So they could give you a point and a slope. They could give you 2 points, but we're always using this point slope form. Now, let's talk about standard form of an equation. Again, if you feel like I'm going too fast, I know that this is probably a review for many of you, but I am recording this so you can easily go back and just go over this portion of it. Standard form equation of a line. You're not going to be asked this as much because mathematicians don't love it this way, but it is written this way, so you need to know that. But the standard form of an equation is ax plus by equals c. Anything written as the x plus a y equals a number is going to form a line, okay? And just for your information, your a, your b, and your c cannot be fractions. And your a cannot be negative. So you would change the equation. If it was negative, you just switch the other signs. And you can have your a and your b be 0, both of them. A and b both cannot be 0. Those are the cannots. But if those all work out, then you have your standard form of an equation of a line. So just to show you, they might write it like this. They might say, okay, graph 3x plus 2y equals 6. And I'm just going to show you two ways to do this right now, just to however you feel comfortable. You could graph this. In this case, you could actually graph the X and Y intercept. So you could do the whole, 0, 0 right here. Plug a 0 in for Y. That would get rid of this. And then just solve for X. Divide by 3, divide by 3. That would be a 2. Plug a 0 in for X. That would cover up this. Divide by 2, divide by 2. Y would be 3. So then you could just graph the X and Y intercepts. So X would be 2, 0, and then 0, 3. And there's your line. That's one way of doing it. I mean, we just went over that in the last section, X and Y intercepts. You could use the graphing calculator, but in order to do that, you have to solve for Y. You have to solve for Y. There's no other way of doing it. So you would have to get Y by itself. So let's see, if I have 3x plus 2y equals 6, I would keep the 2y here. I would subtract 3x over. So 2y equals, it would be a negative 3x when it moves over to that side, plus 6. And then this 2, I would divide everything by 2. Divide by 2, divide by 2, divide by 2. So y equals negative 3 halves x plus 3. And then you could put that in your calculator. Oops, sorry, clear. So alpha window, go over to frac, negative 3 over 2, and type x plus 3, and zoom 6. And there you go. Looks exactly the same as you did up here. So this is just a different form. This is called your standard form. This one is obviously your slope intercept. You would, start at the intercept of 3. Your slope would be down 3, right 2, down 3, right 2, like we were just doing in the other section. Okay. Now for the more meatier stuff of the lesson. We need to know what parallel and perpendicular lines are. And I say this pretty badly with my Jersey accent, so I apologize right now. So my students always make fun of the way I say parallel. They're like, parallel. I don't think I exaggerate it that bad, but they think I do. Parallel lines. And then perpendicular lines. Okay. Parallel lines are two lines would have the same slopes. Your slopes would be the same. They're exactly the same because they have to rise and run the same way. So if you have a slope that's 3 on one and you want a parallel line, then you need a 3. Rise 3, run 1, rise 3, run 1. Perpendicular lines are what's known as opposite reciprocals. Opposite reciprocals. Meaning they both have to multiply to a -1. That's what an opposite reciprocal would be. So if I had a slope of 1/7, my perpendicular slope, that's the symbol for perpendicular, would be the opposite reciprocal. Reciprocal is a fraction, so 7 over 1. And then opposite being sign change, so -7 over 1. These two together, if you were to multiply them, would be -1. These two are perpendicular. If I wanted a parallel slope, I would pick 1/7. So they would be the same. Opposite reciprocals would be perpendicular. So you are going to be asked to find equations of lines, again, that have parallel and that have perpendicular. And so I'll quickly do one of that. So find the equations of lines that pass through the point 3,5 and are parallel and perpendicular. I'm abbreviating because perpendicular is long to write, to the line 2x plus 5y equals 4. Find the equations of the lines that pass through 3,5 and are parallel and perpendicular to the line 2x plus 5y equals 4. Okay, so going back to what we learned in the beginning of this lesson, this formula right here is your best friend for writing equations. You need a point and a slope, and you can write an equation. Point, x1, y1, slope, n. So when I want to write parallel and perpendicular lines, I want a point. They gave us the point. They want us to go through 3,5. So that's our always going to be our x1 and our y1. But I also need slopes. I need a parallel slope, and that's the symbol for parallel. And then I need a perpendicular slope. Well, those slopes are based off of the equation that they gave you. They want you to be parallel to this line, and then they want a perpendicular to this line. So what we need to do is we need to get the slope of this line. How do I get a slope of that line that looks like that? Well, you solve it for y. Solving for y is your best bet for any time you're working with linears. So if I solve this for y, 5y equals negative 2x plus 4, and divide by 5. Which one of these numbers, negative 2/5 x plus 4/5, which one of those numbers, negative 2/5 or 4/5, is your slope? Well, that one next to the x is your slope. So if I want to write a parallel equation, I'm going to use the same slope. The same slope to this line is negative 2/5. If I'm going to write a perpendicular equation to this same line, I want an opposite reciprocal. I want a negative flip fraction. So I'm going to flip negative 2/5, so that'd be 5/2, and I'm going to make sure it's not negative anymore, so I'm going to change it to positive. So now that we have all that information, we have our x1, y1, we have our parallel, same slope as this equation. We have our perpendicular, opposite reciprocal slope to this equation. Now we can write both of those lines, okay? So I'll start with the parallel one. And then over here, we'll do the perpendicular. So my parallel slope, negative 2/5. My x1 was 3, my y1 was 5. And I'm going to put it into the formula, y minus y1 equals m times x minus x1. Just like we did in the beginning of class. So this y stays the same. This y1 will be 5. M is going to be negative 2/5. This x will stay the same. And then this x1 would be minus 3. And again, you are going to have to solve for y, so you're going to have to use the fractions. And I've been trying to show you how to do it on the calculator alpha window. Go over to frac is your friend. Well, let's see, this will be negative 2/5 x. This would be 6/5. And then you're going to add 25/5 to that. Ooh, I'm doing fractions in my head. 31/5. Ooh, I got it right. That right there is the equation that is parallel to this equation. If you were to put this one and this one in right now, for you to put negative 2/5 x plus 4/5, and then you were to put negative 2/5 x plus 31/5, you would see two lines that are going in the same direction. They have the same slope. And and then this one specifically is going through the point 3,5. Now, how do I do the perpendicular? Same way, just with a perpendicular slope. So perpendicular would be 5/2. We already wrote it up here. You're going to keep x1, 3. You're going to keep y1, 5. And you're going to put it into this formula. So let's see. Y minus y1 is 5 equals m times x minus x1. And then distribute and solve. 5/2 x minus 15/2. Ooh, 10, negative 5. Is that right? Yay! I get excited when I can do it in my head. So there's how you would write parallel and perpendicular equations to lines. Now, there's one more tricky question they're going to ask you on this section's homework. Kind of similar to this. And it's just using some words that you hopefully have heard of and seen before. So let me write this out for you. This is find the equation that is the perpendicular bisector. The perpendicular bisector of the line segment connecting negative 5, 7, and 317. Okay. I like this question. It's a little bit of geometry for you, but it kind of goes back to what we were doing last week also. So, and in addition to parallel and perpendicular lines. So we need to find the perpendicular bisector. Bisector means to cut a segment into two. We need to bisect it, find it right there in the middle. Connecting negative 5, 7 and 317. So, I mean, like, let's see if we can think about this. Negative 5, 7 is up here somewhere. 317 is like way up here somewhere. And you need to be able to take this line segment and go to the bisecting point and find out that perpendicular bisector, that line that would cut it so that these two pieces would be cut in half. So really that point that I'm looking for is, if you remember, the perpendicular bisect is the midpoint. I need a midpoint. So I need the midpoint of these two points right here. This again would be like negative 5, 7, and this one being 317. So if you remember how to find a midpoint, you add your x's, divide by 2, add your y's, divide by 2. So if I'm to add my x's, I would have negative 5 plus 3 divided by 2. And if I'm going to add my y's, I would have 7 plus 17 divided by 2. So -5 plus 3 is 2 divided by 2, -2. -2 divided by 2 is -1. And 7 plus 17 is 24. 24 divided by 2 is 12. So this point right here in the middle is -112. That seems about right. That is your midpoint. Now, that's important. That'll just keep that in the back of your mind. Not only do you need to know that bisector part, that midpoint, but you need the perpendicular slope of these 2 points also. You need to make sure you're going perpendicular at that point. So you got to figure out this slope and then tell me the perpendicular of it. So let's say I was to find the slope of the 2 points they gave me, 317 and -57. Slope is easy. y2 minus y1 over x2 minus x1. So my slope would be 17 minus 7, or 10, over 8, which reduces to 5/4. Now, here's the tricky part. This is where people are going to get wrong. Yes, that's the slope, but that's the slope of this red line. And I want the perpendicular bisector. I need the perpendicular slope to this. So what would be perpendicular to 5/4? Opposite reciprocal. So opposite, flip, 4/5. So now I have the slope and I know the midpoint. Now I can write an equation. Goodness, all this for this one question? Yes, all this for this one question. You have to find the midpoint, you have to find the slope and then the perpendicular part, and now you have to write the equation for it. So y minus y1 equals m times x minus x1. Y minus 12 equals, use the perpendicular slope, -4/5 times x minus -1. And I'm going to kind of skip steps here, but just to solve it, you should get y equals -4/5 x plus 56/5. This right here is the perpendicular bisector's equation to those 2 points of craziness. But I saw that there was a question like that, and I wanted to make sure you knew how to do it. All right. I have one more example to do. It's very calculator-y. I'm going to write down the steps for you. I got to be honest with you. I can't remember if it's on this homework or the next homework, but I wanted to squeeze it in tonight anyway. I apologize if it's not on this homework, but I know it's going to be on a future homework, and I know it's a project that you'll have to do in this class at the end of the class. So we're just going to do that, and then the rest of the time is going to be yours to work on homework if you want. And we're going to title this Find the Least Squares Regression Line. Find the least squares regression line. And give me a little quick minute. It's just an example. We're going to do it right now. There's no definitions here. And I'll explain what to do. And hopefully it'll make sense. It's kind of a little bit of statistics in there. These are the projections for net Medicare spending in billions of dollars, shown in the table. And I'll make the table in a minute. Okay. And the first thing it asks you to do is make what's called a scatter plot. And they'll say let x equal 0 correspond to 2018. And then they will give you a find the regression model. And then the last thing will be estimate the Medicare costs in 2024. And then let's see if I can squeeze in my table right here. I think I can be able to. So this is the year X, and this Y will be the cost. So in 2018, the cost was $574 billion. 2019, 642. 2020, 688. 2021, 738. 2022, 833. And then 2023, 852. Okay, so we are going to find what's called the least squares regression line. Very easy. The calculator will do literally all the work for you. First things first, I want to start with this. Let x equal 0 correspond to the year 2018. So really, you're not going to type these numbers into your calculator. You're going to type 0, 1, 2, 3, 4, and 5. Okay? So that's what that part means right there. And we're going to start by entering this data, we're going to call it data, into our calculator. And the way that you do that is you use a really neat part of your calculator called the stat button. So if you see here on the second row, I know you can't see it, but hopefully it says stat. It's right underneath the word delete del. If you hit stat, up comes edit, calc, and tests. You're going to hit edit, and I will write this all down for you in a minute. And look at that. I already have some data in my L1 and my L2. So make sure you hit stat, edit. In L1, if you have things, by the way, located in L1, it's very easy. You just move your cursor arrow up and over and then hit clear, enter. I'm going to do it again to L2. Move it over, hit clear, enter. But you are going to type into L1 your X list. And you're not going to type 2018, 2019. You're going to type 0, 1, 2, 3, 4, and 5. Into L2, you're going to type these numbers, 574, just like they are. 642, 688, 738, 833, 852. You want to make sure you have the even amount here. Okay, so pretty easy to do that. Once you do that, to make the actual scatter plot, I'll say this, you do L1, L2. To make the scatter plot, you go to second and hit Y equals. And right now, if you can see it without the glare, there we go. It says plot 1 is off. Well, we want to turn it on. So if you hit 1, right now it's flashing on the word on. And so I'm going to actually hit enter. I want to turn it on. So again, for those of you who are following me, I did second Y equals. and I turn on the plot. Now, I want it to be on the first type. Oops, sorry for the glare. That first type is scatter plots. This one is a line graph. This one is a bar graph. If you're to take stats, you'll learn all about this. But that first one is the one I want. And then if everything else looks good, it's very easy from here. Once you turn it on, you hit zoom 9. Oh, there's a glare. There we go. Look at that. There's your scatter plot. And it's done correctly according to your graph. So then if this is a multiple choice question, it's easy to pick out right now. Now, part B says find the regression model. Again, the calculator will do all the work once you put the data in. If you can follow putting the data in correctly, then you'll be fine. So finding the regression model, I'm going to quit. I'm going to go back to home. Okay. And you're going to type in the following things. You're going to go to stat, calc, and there's this beautiful thing called lin reg. And I'll show it to you on my calculator as we do it. Sorry about this glare. There we go. So go back to stat. We already edited it. See up here where it says calc. Move over. And then see down here it says lin reg ax plus b. Doesn't that look very familiar to us? Mx plus b. Go down to that, number 4. And it's going to ask you questions like L1, L2, sure. Hit calculate. And the calculator did all the work for you. This is an awesome thing. Now, you may or may not have this r squared r stuff. Don't worry about it. But 57.5, that is your slope. That goes in front of the x. Y equals 57.5. Then you put your x. Then your intercept, your b, would be 577.38. And so if we were to interpret this, this would be your initial amount when X at year 0, or actually at year 2018, our initial amount was about 577.38. Is that correct? Well, no, we're off, because this is just kind of using this information to make an equation. So it's close, but it's not completely accurate. This is our rate at which the cost for Medicare spending is increasing per year. That right there is your rate at which it's increasing. So if I were to then answer part C, which says estimate the Medicare cost in 2024, how would I do that? Well, 2024 is actually, remember, it's our year 6. And where would we plug 6 in, for X or for Y? Well, we'd put 6 in for X. So we would actually use this regression model and do 57.5 times X being 6, because that would be what year 2024 is, and add 577.382. And you would get roughly, so in the year 2024, I would have roughly $922.38 billion. Okay, now, again, let me just forewarn you, your calculators got the stat plot on. I can't remember if this is in this section. I might look at it up right now, but you might want to go back and turn your plot off so that way you can graph your lines correctly. So just hit second y equals, hit number 1 and turn it off. And that way, if you want to graph your lines later on for like what you're doing in class, you go to, y equals right there. And then notice, see how it says plot 1, plot 2, plot 3, all the plots are off. So you're good. So you can go, zoom 6 is your standard view. Zoom 9 is your statistical view. So